So Philip over there sits down now, and the robot should, at some point, I don't know whether already, maybe in a moment, recognize that there is a customer there. And we'll start to serve it. Yeah, that looks good.
Hello. Please order by pointing at one of the drinks on the menu card.
So we have a menu card here. Oh, sorry. That is sulfuric acid, which he tries to order.
I am sorry. We only serve this to robots. But if you'd like, you can choose a different drink.
Okay, feel free to go ahead with the water, I guess.
Well, you can order by pointing at the drink of your choice on the menu.
Okay, so as you see, there's computer vision integrated here. First, we recognize that there's actually a human behind the bar by recognizing the faces and clusters in the depth image in combination. Then we move towards the bar, look down, look for a menu card. When the menu card is not there, we actually tell the user, try not to fool me, that doesn't make sense. Or, well, show me what to order. Next. That doesn't look too good. This is actually navigation issues. So this is one of the stacks we didn't really modify ourselves. This is move base, and I guess everyone who worked with autonomous robots has seen something like this before. The robot looks down, recognizes in the RGB image of the camera, which is up here, the menu card by feature template matching, and recognizes the finger using more or less traditional computer vision approaches to recognize what the human ordered by detecting the tip of the finger of the image. We recognized, okay, the user wants to order water, which is the shortest demo we have because it's only comprised of because it's only composed of one drink. So we have a recipe list, of course, for all the others. Some of them are not here right now, but we can try Tequila Sunrise afterwards in case everything works. So it recognizes the recipe and starts pouring the drinks one after the other into the glass that you see over there. In this case, going to water is somewhat easy. Then for manipulation, we heavily rely on the Move It framework, which we also modified. So there was a modification presented called Move It Task Constructor at the last ROSCON, which was last week. So you see that over there in the menu on the bar too. The idea here is peak, of course, is not a single, well, it can be a single motion, but it's not a single primitive motion in the sense of going from A to B, because usually you want to approach the object rather reliably, in a reliable way, without colliding with anything. You want to grasp the gripper, close the gripper and lift the object off before you start moving away again. This is composite motion planning. So now the robot already said, okay, I know, I found a way to do it. And Benjamin hopefully looked at it and said this was going to be okay. And it will pick the bottle. And move it with an upright constraint into a transport pose, which we defined beforehand. The object, I didn't talk about the bottle recognition here yet. The bottle recognition is based on surface segmentation, including cluster detection on top of the objects, which is more or less the standard tabletop segmentation pipeline you have. But we afterwards extract sub-images that correspond to the clusters from the RGB image, and trying to convert a relatively simple convolutional neural network based on like 1,000 images, 1,500 or something, per class to classify the drinks we have available. So that afterwards we have a cylinder segment, ransack on top of each cluster, can classify everything correctly, and that's why we recognize that there's actually the water right there where it is.
I know how to do this. Right?
Now we want to pour, which is obviously the most critical part of this demo. So Benjamin verified that, and we can pour now. As you can see, in case you don't know, yeah, we have to do fine adjustment, maybe. We're actually not sure, but we want to be on the safe side. The pouring motion is The purring motion here is hard-coded in Cartesian space relative to the center axis of the glass. So we try different, also using the task constructor framework, to have different Cartesian trajectories, and only execute the motion, start of the motion when we are sure that we can actually do the full purring motion going towards the glass and back from the glass without actually violating this upright constraint. As you've seen, I was just going to explain that, sorry. As you've seen, there was an actual glass on the table. Now everyone who worked with RGBD sensor data knows that you don't see glasses. We do. So it turns out, and there was also a paper on that a couple of years ago by Michael Letz's group, that you can look into the IR image of the RGBD camera and you will see some differences. And if you do some very intelligent high-pass filtering combined with median filtering combined with a number of other standard computer vision techniques, you can actually estimate the bottom and the whole blob of the glass, which is what we did here, which is also why it might not be 100% perfect, but then it's based on the RGBD image. So the resolution of that is limited too. Now, afterwards, it wants to place back the object on top of the table at the place where it found it. And as you've seen, again, there was a minor problem with move base. And I hope that was the only problem. We'll see. So move base ended up telling us, you know, you've arrived in front of the table, right at the position Benjamin moved it to, just like 50 centimeters off. And it claimed that it was there, and yeah, you know, software bugs. So in the beginning I said, the question was how far can we get? We only had like 1 week, we've never seen the robot before. One of the things we did not implement properly was placing the object back. So we know where exactly the object is. We know, wait a moment please. So we know where the table is approximately. It's already in the planning scene. This is previously specified information in case you'll ask the question again. We usually recognize everything that is on top of the table, but we do not recognize the tabletop surface explicitly at the moment. We use it for object segmentation. For placing, we don't at the moment. So the robot expects that it stands right in front of the table and will place the object on the height of the table. We know, yeah, go ahead please. And of course, you might have also seen these bottles are quite nice, but they're also a bit unstable on the bottom. Okay, with water inside it actually works more reliably. Okay, again there was task constructor movement. Planning all together, and apparently one of the last minute changes failed, but it still worked. Okay, and now it goes back to idle mode with the updated scene description of everything that changed in between, and we could do another round. And oh, okay, and again a localization problem. So apparently it's standing in front of the desk, in front of the bar right now. Okay, so thank you.